In June 2001, MG wanted a change of image. They called it Project X-Power SV. The objective was simple: go to Modena in northern Italy and build a 200 miles per hour monster. MG supercar in the making next.
You're watching Motors on Men and Motors.
You're Britain's biggest car maker, but you need a new image. What do? You build a supercar.
Well, if I take you back in time, just over 3.5 years ago, a group of us who became known as the Phoenix Consortium were wrestling with the challenge of taking over the then Rover Group from BMW. And I had the responsibility for penning a product plan. Part of that product plan, possibly the key part, was what I described as the relaunch of the MG brand. We had a plan to turn MG into a brand that had full model coverage, and we've achieved that. But at that same time, I wrote down one additional product that I called MG Ultra Car, and the SV is that car. Why Ultra Car? What was it meant to do for the MG brand? Well, MG is a very, very strong brand, but if it had a weakness, maybe it was looked upon as slightly historic and old-fashioned. So I was determined that we'd have one product specifically that was an absolute technology demonstrator, that demonstrated that MG wasn't just about the past, but was a brand for the future. Highly technological, almost a crazy concept. A car that would take on the best in the world, and particularly gun for those supercars coming out of northern Italy.
To create the Ultra car, MG turned to one of the world's leading car designers, Peter Stevens. Peter Stevens was appointed as the product design director of the MG Rover Group to revamp the company's range of vehicles. Peter had previously worked with McLaren, Lamborghini, Jaguar and Lotus, among others. With the Jaguar XJR15 and both the Lotus Elan and Lotus Esprit to his credit, his most famous design to date is the coolest car in Christendom, the legendary McLaren F1 supercar. He now turned his celebrated talents to the design of a new supercar, the MG X-Power SV. His brief was simple but exacting. Produce a radically new high-performance MG based on the company's traditional core values of high-speed, fun motoring. And make a prototype in time for the British Motor Show at Birmingham in October 2002. Just 13 months away. Fortunately, MG had recently purchased the company of Cavalli, based at Modena in Italy, that was building a Grand Touring sports coupe. Named the Mangusta, or Mongoose, the car was ready for production, and, crucially, the design had passed all current US and European crash regulations. An initial idea was a simple makeover of the Mangusta, a reskin and retrim in motor manufacturing jargon, but this was soon discarded. A radical reappraisal was undertaken with the project now designated MG X80, with the main design office at Modena in Italy.
As a designer, when I look at the history of a car company, I don't look back in order to sort of pillage a box full of goodies, door handles and louvers and vents, and stick them onto a car to try and get some heritage. The way I look at the history is to see what the philosophy of the company was in the past and how that is relevant to a modern car. With the SV, I look particularly at the MG K3 because that was a fascinating car. It was built in 1934. It was a car in which you could drive down to Italy, to the Mille Miglia, win the class and drive home again. So this was a racing car you could use on the road. Not only for racers, of course, but wealthy clients of MG could buy one to use on the road themselves and imagine they were winning the TT in Ireland or 500-mile race at Brooklands, for example, or in fact the Mille Miglia, which was the kind of classic one to win. So that to me was very important as part of our imagery of the SV, racing car for the road. It was an interesting discovery I made whilst researching the MG K3 Magnette. That was that mid-1930s was a very expensive car. If you looked at that car in today's money, that would be something like a £110,000, £115,000 car. So we're not talking here of any superficial little thing at all. Very serious car, serious money. Interestingly, of course, the K3 that you could go out and win races with was very, very much cheaper than competitors such as a Bugatti. The great thing with SV is, of course, we are very much better value, especially with our high technology that's in the car, than our competitors.
Well, I was very clear from day one. By definition, Ultracar was a race car for the road, and we were going to use race car delivery techniques. And by that, I mean a small team dedicated to the project, using the highest possible technologies and focused on very short lead times with minimal management intervention. That's how we've delivered the car.
One of the first things that I felt was crucial was that this had to be a very high-performance car. And part of that high performance is getting the weight down. We set an aggressive weight target of around 1,450 kilos. And having chosen that target, it was apparent that we had to make the body out of something that was light and stiff, and we chose carbon composites for doing the body. Now, also part of our weight reduction exercise, we looked very carefully at the Mangusta chassis that we had inherited with the company. We took weight out of that, we made a stiffer structure, and we revised the suspension geometry because, again, part of our view of a much higher performance car was that it should have absolute class-leading, really race-orientated suspension.
The first thing I did was to bring on board a few people that I thought would be essential to this project, people that I had worked with before or I had seen working and had great regard for. One of those, Giordano Casarini, was one of the strengths of the whole Cavalli project because he had worked originally with De Tomaso and then with Cavalli on this car. It was in his blood. He knew every nut, bolt, washer, detail, performance requirement of the car. Absolute tower of strength, a man with infinite passion for the product. The other man who was essential was Ian Morton. Ian Morton I'd worked with at another British company, and in fact I persuaded that he should leave those people and join us to look after production. And 2 or 3 engineering friends of mine who live in Suffolk as well. We're sometimes seen as a kind of East Anglian mafia. They work as consultants, and we've done projects for people as varied as BMW and Audi and Bentley and Lotus and goodness knows who. You know, absolutely trusted people who don't understand leaving at lunchtime on Friday, you know, and who don't understand doing things quickly and badly. You know, quickly and brilliantly is all that we know about, really. So these people came on board as the start, really, of the whole project. When you're talking about 200 cars a year, I believe you can afford to offend some potential customers with the strength of your design statement, because you will attract just as many others who understand what you're trying to do because they will run their lives in a similar way. It's not an overly complex shape. A lot of the detail is driven by either the aerodynamics, because when you're designing a car that could do 200 miles an hour, you have a great responsibility to those who buy it that you make a car which is stable at very high speed. Aerodynamics is one of the bits I like. I actually like that constraint in design, because since I do the aero stuff as well, you know, I feel I can embody those technical bits with the style that I enjoy doing. Also, when you've got an engine which is producing somewhere between 3, 4, maybe up to 700 horsepower, cooling is very important, and it's easy to forget that, fall in love with the kind of style of the car, and then, much to your amazement, it boils the first time you go out on a test run with the thing. So I was very keen from the start that we understood the airflow management for the cooling, both in and out of the car. That's why there are ducts and louvers in places which are very important for controlling the air, controlling the temperature. Also, I would have to admit to having in mind a potential racing life for the car later on. And there are some elements of the car which will benefit us very much when we come to go racing with it. So things that may not be immediately apparent will become so.
MG is one of the oldest names in competitive motorsport. From endurance racing, such as the grueling Le Mans 24-hour sports car race, to the rigours of motor rallying. After many years of track and rally success, MG Sport and Racing has acquired a wealth of experience that has been synthesised into the design of the SV.
With the SV, which is capable of over 200 miles an hour, it's very important that the vehicle is stable and that the dynamics of the vehicle are fundamentally right. We achieve this by placing the engine behind the front axle line and having a superb suspension system with long wishbones, like a racing car.
With double wishbones and independent coil springs all round, the suspension is finely tuned for optimum damping and road adhesion at all speeds. Such a layout provides maximum handling and steering feel, with the driver at the core of the machine. The switchable traction control and powerful Brembo disc brakes, combined with the specially developed Michelin Pilot Sport tyres, gives the SV progressive and predictable breakaway characteristics for complete reassurance, even in the most extreme of driving conditions, and at speeds around 200 miles per hour.
The first thing you have to do is make sure that it is fundamentally safe at those kind of speeds. Some of that work takes place in the wind tunnel with the aerodynamic development so that the car is basically stable on the road. Obviously then the great thing that concentrates your mind with a 200 mile an hour car is that you have to have spectacularly good brakes and you have to have very responsive but very predictable handling. So you have to put those elements in place first. After that, you have to make a car with a very strong structure. Now this car's got front and rear crash structure which complies with American, European and all world requirements, it also has a very stiff rollover structure. Having made a clear decision on the materials and techniques that we were going to use for the X-Power SV, my task was to develop the design of the car, aerodynamics, way it looked, interior. But in parallel with that, Giordano Casarini, our chief engineer, and Ian Morton, who looks after our production as production manager, really were set off to scour the world for the best suppliers, the best materials that we could find, and to look at the latest techniques, not only for carbon fibre production, for example, but for steel work, for the kind of chassis that we wanted. They had, I suppose, 3 or 4 months to do a very thorough survey of what was available to us. That was fed back to me whilst I was designing the car, so I wouldn't be designing things that became impossible to make in our chosen methodology. Carbon fibre obviously is a very fundamental part of that. I had decided early on that carbon was not only an interesting material to use for the body, but it has enormous advantages when you're looking at a comparatively low volume production vehicle. It's obviously very stiff, it's also strong, it's very light, and moulded properly is extremely consistent in the shapes and dimensions of panels that you get. It also has some properties which I suppose aren't particularly applicable to sports cars when one first thinks of it. It's a material that was at first developed for aerospace industry.
Similar to the material used in the construction of the B-2 stealth bomber and the F-117 Nighthawk stealth fighter, the manufacturing process of the carbon fibre composite is a closely guarded secret. Unfortunately, it does not make you invisible to police speed cameras. Produced by SP Systems on the Isle of Wight, the carbon fibre composite material is a sandwich of epoxy resin and lightweight scrims that provides great strength with low weight and a stable surface for optimum paint adhesion and chip resistance. Each car's 3,000 composite pieces are laser cut into precise shapes and then shipped to Italy and formed into the body panels of the car.
Our choice of carbon fibre as a body material, not only for the more obvious reasons that it's stiff and light, but its engineering properties are very interesting compared with steel. For example, strength for weight, you can be 5 times as strong as steel, or if you go for an equal strength, then you can be only a fifth the weight of a steel panel. The other great bit with carbon is that it is a tunable material, so you can choose at which point you want the advantage of the weight or the advantage of the stiffness. Of course, the advantage of the weight for a high-performance sports car like the SV is that it's kind of like free horsepower, because that horsepower that you have available to accelerate is pushing a lighter car, and that means it's going to be quicker, and that's what we believe our customers are going to like. Having found our material supplier, obviously the next thing we had to do was look at how we would get that material from the supplier into a tool to make components. And in collaboration with SP, we came up with a system where we cut out all our pieces of carbon fibre, almost tailored, you might say, like a very expensive Savile Row suit. Wonderful machine that not only does it cut out the material for us, it marks the part number onto it. It also shows the orientation of that component within the tool. We then put those carbon sheets into a box which really is rather like a pizza box, They go into a refrigerated truck, which then goes down to Italy, where it delivers these ready-to-use pieces to our moulder in Italy. Our moulding company in Italy, a company called Belco Avia, take the raw carbon fibre pre-cut elements, put them into the tools, produce the panels by both heating and pressure on the material. What we get out of the tool then is this tremendously light, stiff panel. The great thing with those panels, and something that was very important to us as a motor manufacturer, is the conformity of production. We need all the pieces to be the same, because the only sensible way to build motor cars these days is to build them exactly to your design and drawing intent. It's no good having a system that you then have to bend or file or hammer or fiddle about with, because that wastes time, and you never know what shape the car is exactly, and when something doesn't fit or work, you don't know why. So it's become fundamental to this project to know that what we're making is exactly like what we designed. Carbon fibre gives you that opportunity, because within sort of 2 or 3 hundredths of an inch, the panels will be exactly as you want them. That means that when it comes to fitting the panels to the car, we have some very sophisticated aluminium jigs that the carbon panels clip into in a way which I can only describe as perfect. Everywhere is exactly in the right place. These jigs then slide up to the car, both from above, from the sides, front and rear, holding a panel. Those panels are then bonded or mechanically fastened with bolts onto the car, and they will be in exactly the position we want them to be. What happens with a steel chassis is that the tolerance is never as good as with carbon. You can expect, I mean in our case we do it very carefully, so we're looking at tenths of an inch with the chassis. There are some cars which are looking at quarters of an inch at least. We're looking at tenths of an inch with the chassis, hundredths with the body. So we need to put the body exactly where it should be, and then bond it in that position. Then we know the doors will open, the seals will work, the windscreen will fit in, the wipers will work, all the things that have to happen. So our jig system allows us to do that very effectively. Some of our carbon fibre panels are what we call double skinned. That is that, for example, with a door, you'll have an outer carbon panel and an inner panel which will pick up the window lift mechanism, the speakers, door handle, those kind of things. And in fact, in the door's case, there's also a steel member in there, which is part of the side crash structure. Now, we bond those together and we bond the steel into the door. And what we had to do here was also interestingly different in that we developed different glues of different stiffnesses that would harden in different times, because we want a little degree of flexibility there. Obviously, carbon will expand in heat at a different rate from steel, so the bonding has to have a certain amount of flexibility in it. Some things that we want to be bonded so that they become one rigid structure will use quite a different glue. So it's one of the areas where I think a lot of our research has paid off in finding more sophisticated solutions. The chassis of the X-Power SV is a steel structure, but it's not, again, it's not a normal steel structure. It's made from a very light, high-strength steel. Our chief engineer, Giordano Casarini, had already worked with people in Italy called Vaccari and Bossi, and he introduced our little team to them. When you go there, you discover they make chassis for Lamborghini, and then you discover they make chassis for Ferrari as well. They were happy to work with us developing this higher strength steel, and to maintain and increase the rigidity of the structure whilst taking weight out of it. Mr. Bose is a powerful character who runs the company. He has a passion for steel, so a delight to work with. And one of the things we wanted him to include in the chassis of the car was that it should have a tubular rollover structure that complied with FIA motorsport regulations, because we believe that in a very high performance car such as the X-Power SV, you really want to make the best and safest structure that you can. The other thing, of course, that is important with this kind of chassis is considering not only crash regulations. You can make a car which passes the rules but isn't necessarily tremendously safe. So what we wanted to do was make a structure which looked after the occupants in the unfortunate event of an accident. We chose an all-aluminium V8 engine. We chose it for a number of reasons, really. It's an American engine. It's made by Ford in America, but it's modified for us. Two different people who do that. One is a company called Sean Hyland in Canada, and the other is Roush Industries in America itself. You know, I like the sound of a V8. I think an American V8 sounds great.
It's a simple V8, 4.6 litre, 4 valve per cylinder, double overhead camshaft, equipped with a T45 transmission that we modify, changing the fifth gear ratio and changing the flywheel, making it lighter for better and more crispy acceleration. The unit is very compact, it's all aluminium. It's the state of the art of the modern technology for V8 engines, and gives to the car an incredible value of torque and power. The noise of this engine is absolutely impressive. It's not a noise, it's a music.
It's a very effective piece of kit, really. They get tremendously good torque. You know, torque's what it's all about when it comes to sort of startling acceleration. Wonderful durability. You know, that just comes as part of the package, if you like. When you combine that with the Tremec gearbox that we have, you get an effective powertrain there. And what we did when it came to the final drive unit, the differential, we went to Australia because Australia never gave up on the V8 engine. There was a period when Americans went what I would call soft. They went to 4 cylinders and V6s and things. You know, Australians stuck with very strong V8 engines, and so their development process for making tremendously strong final drives, in this case with a very interesting torque limiting device, which instead of traction control that robs you of the horsepower that you needed to accelerate, simply distributes the power to whichever wheel is going to make the best of it, really. So we went to this Dana differential, and it's typical of the way we chose the pieces, really, because again, when it comes to braking, which is as much an essential part of a sports car as the engine is, we worked with Brembo in Italy. Brembo make brakes for Formula One cars, they make brakes for Le Mans cars. They really know how to make good brakes. And so we get spectacular braking because of, again, that relationship with the company. You don't just go out with a shopping basket and buy 4 brakes and stick them on the car. You have to work with the company to develop the braking that you believe the car should have. That is the best that's possible. So Brembo's the partner there. It brings us to the wheels, really, if we work logically through the components of the car. A company called OZ in Italy, again, famous for Formula One wheels, for wheels that have won Le Mans. That's a company that I've worked with in the past, and I've always had extraordinarily good relationship with them. We can have a wheel which we think looks good, suits our car, and has all the qualities that you want from a really high-strength wheel for a kind of racy car.
So the engine is now in the car, has been slided in gently in the car, and this is a feature of our chassis, that the engine can slide into it, like in a race car, and as easy can come out. No need to have it come out usually, but it's easy to take it out. One important feature to notice is that the engine is in the front of the car, but is behind the center of the front wheel. So it's not a front engine, it is a central front engine. This is one of the features of this car. After the engine has been installed, we will fill it up with proper machines that do the filling of the fluids, not in the way we think are right, but in the right way. We'll empty all the circuits and fill it up properly. Then it will go through a computer programming of the passive anti-theft system, and it will go through a complete checkup, checklist of electronic features, and at that point it will be started. And this is the end of the assembly line in Modena.
The car that leaves Italy is essentially drivable. All the mechanical elements are there, the body panels are on, but at this stage it's not painted, neither is it trimmed.
In the past, it was extremely difficult and costly to produce a WEEE-free paint finish for a carbon fibre-bodied car. While this was not a serious problem on an F1 racing car, it was unacceptable for a high-performance sports car on general sale. Previous supercars with composite bodies such as the McLaren F1 cost as much as £30,000 each just for painting to the desired degree of finish. For the SV, the manufacturers have devised a new painting procedure that gives a durable mirror-like finish on a smooth surface. The MG X-Power SV is a two-door, two-seat sports coupe with a front central engine and rear-wheel drive configuration. It comes in several versions. The entry-level model is powered by a 320 horsepower, 4.6-litre all-aluminium quad-cam classic Detroit V8 engine. It propels the supercar to 60 miles per hour in 5.3 seconds, and on to a governed maximum speed of 165 miles per hour. Automatic transmission and higher-powered SVR versions are also available. The SVR is powered by a 5-litre V8 engine tuned by Sean Highland Motorsport of Canada with a 5-speed Tremec gearbox. The MG X-Power SV Club Sport features a more powerful 5-litre Roush Industries modified V8 with a top speed around 200 miles per hour and electrifying acceleration. Built to special order, the SV Club Sport version is more at home on the racetrack, where its performance can be enjoyed to the full. Employing a combination of GPS and mobile phone technology, a device incorporated into the SV runs a diagnostic check each time the car is started. Any potential problems, such as a defective light bulb, are readily identified. This data is transmitted to the X-Power call center, and the SV owner is contacted immediately. The Omitech equipment also acts as a tracking system and vehicle immobilizer in case of theft.
The MG X-Power SV is the first vehicle of its kind to be fitted with the Remote Service Platform, or RSP. The RSP is a fully integrated system developed by Omitech. The system provides the ability to continuously monitor the condition of the vehicle and to be able to recognise if a fault occurs on the vehicle. It also means that should the mill lamp come on the dashboard, we have the ability then to dial into the car to actually look at what the fault is on the car and to be able to recommend to the driver the next course of action. The unit also provides a valuable lifeline to the emergency services and the roadside assistance provider. Through the operation of the simple rocker switch, the RSP can make a voice call to both the emergency services or the roadside assistance company. And through the integrated telematics system, the location of the vehicle can be readily identified, even should the owner be lost. In the unlikely event that the MG X-Power SV should be stolen, the module offers the ability to track and locate the vehicle and then to immobilise the vehicle in a safe and appropriate manner. We also provide the facility that should the owner wish to leave his car for a period of time, we can actually remotely lock down the car for that period of time, preventing access to the car and preventing the car from being started.
As befits a high-performance car, the controls and instrumentation are simple and functional to minimize distraction to the driver. With raw carbon fibre a feature of the vehicle interior, the cabin trim can be configured in numerous combinations, from the refined to the eclectic.
We've chosen leather or a leather and Alcantara mix. Alcantara is an interesting material. It's almost like a mock suede, but it breathes very well, it trims very nicely, and if you're doing a very high performance car, then you can make a seat and it really grips you. So if you want to do track days or some kind of more exciting driving, it's something that we like to offer the customer. Typically, of the way that we looked at all the components and looked at new methods of doing things in the car is the way that we organise the seat belts. We made a deliberate choice not to fit a standard airbag system because a number of reasons. On a very high performance sports car, the weight and inertia of an airbag steering wheel can totally corrupt the feeling of the steering. And if you go for a much lighter steering wheel, much simpler steering wheel, you get a much better feel with it. But also, although it's not a subject that one likes to go into in great depth because everybody will naturally believe that someone else is having an accident and not themselves, but it's realistic to consider that if a very fast car like this has an accident, it could be a very large accident. And the thing with an airbag is that once it's deployed and collapsed, it doesn't do you any good any longer because it's done its business. What we've done instead is work with a German company to develop a 4-belt harness, so there are 2 lap and 2 over the shoulders, and then that is controlled by an electronic system that if it sees any untoward, any strange movements in the vehicle, it locks solidly, not like an inertia reel where it starts to stretch before it happens. It locks up immediately. Or there's a switch inside the car that if you come to your favourite bit of downhill, uphill road or something, you can flick the switch and then it works like a racing harness where you're clamped in properly like you would be in a racing car. We think a much better solution. What emerges from this kind of list of partners really, when Giordano and I laughingly talked about it, is that it's all our friends from previous projects that we have found that we work best with, that almost like a wedding really, we've brought all our different guests with us. Giordano's group will sit on one side of the church and my group will sit on the other side. And it's one of the things we've done during the project is to have these group meetings with all our suppliers so they can talk to each other. We can have a fine lunch and we can have some wine or some beer or something, get to know each other and realise that we're all contributing to the same project. You know, and that's part of, I think, the essence of this, which is so exciting for me and probably one of the reasons why it's ended up so successful. The outcome of this that I suppose lightheartedly refer to as a wedding is that we end up with the MG X-Power SV. So we end up with distillation of all that energy and enthusiasm from these various parties. That's, I think, what gives us a car which has such a lot of personality, because it's got everybody's spirit and passion in it. It also gives us a car that we can tune to really the customer's request, because although we start with a pretty strong 320 horsepower engine, we will have the opportunity during the development of the car to go to 385 horsepower, 410 horsepower, and an engine which is interesting to us, 765 horsepower. Now that's something that we've developed in a project that we've done where we've run one of our ZTT, that's our MG Tourer, at Bonneville, with the engine that will be eventually available to customers. That's an engine that was able to push this large estate car to a speed of 225.609 to be exact, miles per hour. So we know it's a good engine, we know it will live out in the desert with temperatures way over 100 degrees. We know it makes a great noise.
Last mile, 220.733.
Obviously, with a program like the MG X-Power SV, we're not looking at just kind of a one-shot launch and it's done. We're looking at a 4-5 year program. And during that program, we expect the car to do lots more things for us. And we're certainly looking very seriously at the idea of GT racing, for example, absolutely within our plans, as are these high-performance engines. And the engine that we put into the ZT Tourer, that's a standard MG estate car. Nothing fancy, a small amount of aerodynamic tuning that I did on the car to ensure its stability. But an engine that can push one of those to 225 is going to be quite exciting in an SV, because obviously we're looking at less weight, less frontal area, lower drag, something quite dramatic, that's for sure. You always need to be pushing the boundaries. That's why if you go to Bonneville, you're testing yourself as well as the product, you know. Can I put together a project that can do this kind of extreme performance? And I always like to discover whether I can do that and enjoy it while I'm doing it.
High in the hills above Modena is the testing ground for many Italian supercars. From Ferrari and De Tomaso to Lamborghini and Maserati. They now have a serious rival. Based on a long tradition of excellence, the MG X-Power SV was conceived in the depths of the English countryside, nurtured in the hub of the Italian supercar region of Modena, and refined in the industrial heartland of Britain at Longbridge. It is a true race car for the road.
Next tonight, it's more than just the wallet that takes a dent. Ouch, that had to hurt. In just a moment.
MG X-Power SV, The Making of a Supercar, is available on DVD, priced $13.99. Call this number to order.